there really is a feeling among social science researchers, or traditionally there was a feeling, that figures were kind of superfluous. Like there was this sense of like, well, yeah, let's put together some simple summary figure. You know, they're kind of something trivial, there's something simple. Not among all researchers, but there is this sense floating around in a lot of social science research. Like, you know, the serious people look at tables and the less serious people look at figures or something like that, or can only understand the figure. And so I think that's an idea that one should push back against, precisely because graphics and figures can illustrate patterns you can't get in a table. In fact, sometimes they're the only way to understand certain relationships. So here are 4 different data sets. Okay? And these are just small number of data points. You see the x variable, you see the y variable, and it turns out these 4 data sets all have the same mean for the right-hand side variable, all have the same mean for the dependent variable. They basically have very similar statistical properties in terms of, the best regression fit. Really, all these sort of diagnostics from a regression look exactly the same. Obviously, they're constructed to be exactly the same for these 4 data sets. The correlation between the variables is the same, et cetera. So you could look at this, and I can look at this x and y data till I'm blue in the face, and I'm not going to really get much of a sense of what this data looks like. But if I were to look at these and say, hey, all of these have the same property, they have the same properties, all these moments of the distribution and the fits are exactly the same, it's kind of like the same data, right? Maybe, right? That would be our intuition statistically. Well, it turns out these are the 4 data sets, 1, 2, 3, and 4. One of them looks like real data, not a very good fit, but there's maybe a linear relationship. Some of these are totally rigged data with really strange properties where it's not even clear what the right fit is or what the right model is that would generate this kind of data. But they have the same basic statistical properties. So this is just an example where plotting your data, just the scatter plot, is going to tell you immediately what the right sorts of specifications would be and tell you a lot about the data. You might be able to identify outliers. You might be able to do a lot of things just by plotting the data. So it's, even though people are better, again, today than 5 or 10 years ago at visualizing, plotting their data, people very often don't do this in an effective way. They start analyzing the data and running regressions before they've done some of the basic diagnostics on the data that they're working with. And so this is an example of where it could really fail. And this is already 40 years old, and people are still tweeting about it. So it's got to be pretty good. There's some really good real-world examples, and this was emphasized also in the Tufte book, if people remember. So Dr. Jon Snow, extremely famous physician, British physician, no relation to the Game of Thrones character. At the time that he was a physician, there were regular outbreaks of cholera and other infectious diseases in London and other big cities. And physicians were sort of worse than useless in the sense that they had a whole bunch of theories that were totally wrong and led people to be much sicker than they would have been if there hadn't been physicians. And that's probably true until maybe like 1910. People have tried to look at the data at which the median physician actually improved people's health rather than made them sick. So they've had maybe 100 years that they've been on the positive side of the ledger. But he was one of the good ones in trying to figure out what was going on. So at that point, people thought, these brilliant physicians, thought that cholera was spread by bad air and miasma and all these other things with no basis in science. And they didn't understand that a lot of these infectious diseases were waterborne. So what did Jon Snow do? There was an outbreak of cholera in a very populous neighborhood of London. He decided to plot the data on a map. So he plotted the data. He got the data, and all these dots are where people died of cholera. And then he plotted various other things on here, various locations and water pumps. He just decided to plot stuff. And he found this completely striking pattern, which is the cholera cases were clustered around this one water pump on Broad Street. Right around here. The people who lived near the other water pumps weren't dying of cholera. And it turns out he went and talked to people here, because there were some people dying over here. A number of the people in these outlying areas who died were people who either went to school or worked in this area and drank from that pump. Other people were people who just liked the taste of the water from that pump and would go there from farther away. So he basically did modern epidemiological research or something approaching modern research and identified this incredibly strong correlation between drinking from this water source and getting sick from cholera. Of course, nobody believed him that it was water related, and it took decades for others to buy it. But it turned out this water pump had been dug at a very shallow depth, right near an old cesspit, like an old latrine. And the cesspit had sort of been covered up and sort of forgotten about, or when they dug the well, they didn't go deep enough to avoid it, and basically was leaking, fecal matter into the water source, and that's what was killing people. So it was like, today it seems obvious that was the source. But he discovered this relationship, and within a couple decades, this insight had caused major cities all around the world to completely redo how they structure their water systems, their sewage systems. So this was research that not only kind of launched a major intellectual field, but this research saved, if this research speeded up the adoption of good hygiene practices and sewage practices, it might have saved millions of lives. This is like maybe some of the most influential research, we've seen. So Tufte writes, of course the link might have been made statistically, like maybe he could have gotten data on the distance from different water pumps or, locations and run a regression and sort of figured out there was some sort of correlation with some good luck. But here, it really feels like the graphical analysis sheds light on the data much more effectively than statistics do, because he may never have even realized the link with the water pumps if he hadn't sort of visualized lots of data. He probably plotted schools and churches and all this other stuff. He said, wait a minute, it's like this water pump. And then he started doing interviews and he sort of built on it. So this is a case where statistics aren't enough. Another thing that I think is effective is, first of all, statistical analysis wasn't that developed at that time. Modern statistics emerges after this point. So it's not even clear the statistical tools were there. There weren't even computers to do the analysis. Like, how would he have done this statistical analysis? Like, he kind of had to do it graphically. Like, today we have some hope. There's something very powerful about simple graphics, or I don't want to say simple. There's a ton of data on that graphic, so it's not simple. But there's something powerful about graphics that makes them immediately intelligible to people. So even government officials then, who didn't know statistics and whatnot, could see the relationship and understand it immediately in a way that a statistical relationship might have been just much harder for them to grasp. So this was like a particularly effective way of understanding this important relationship.